mi alzo, faccio la mossa di alzarmi e me lo porto dietro. Siamo già pronti? Okay. So, good morning to everybody. My name is Nicola Spallanzani. I work at Cineca in the department, the High Performance Computing Department. My work is mainly consists on helping researchers, probably like you, okay, that want to access to our supercomputers and use our supercomputer for their research. And what I do is to manage the supercomputers, manage the software that we install on the supercomputers for the researchers. Usually we provide to the researchers the main used softwares, and they are accessible to in our cluster via a module environment. So one of my work is to manage those softwares, and the other part of my work is to manage courses and schools organized by our department. Your colleague Mirko asked me to introduce you how to obtain resources, Cineca resources, how it is possible to work in our supercomputers, how to win a call, win some a grant for have resources in our supercomputers. There are two ways mainly. The first is to participate to a national call, a national project called Iskra. So you can search for Iskra. If you type on your browser iskra.cineca.it, you will be redirected to this page where it is explained what is the Iskra project. It's the project that we use to assign supercomputing resources for Italian universities, Italian resource centers. Every researcher that work in one Italian national institute can apply for this at the call provided by this project. There are two types of two class of project that you can apply for, Class B and Class C. It's missing Class A because it was substituted in the time, so we decided to continue to have to maintain the old names. So the Class A it was present some years ago, but now it is substituted by the PRACE project. I will explain you later what they are. So you can participate to these two class of calls. Okay, they are different in two ways. The first is that is the amount of resources that you can ask. Class B projects are higher, more. You can ask for more resources than Class B project. The second difference is that for a Class B project, you have only to pass a technical review, okay, just to check if the code that you want to use in our machine is good for our machine. About the Class B project, you have also to pass a scientific review. So we have a panel composed by some professor from many of the Italian university that take care to review from a scientific point of view the validity of your project. So when you have, we have a list ordered in terms of good scientific projects, we can assign resources to the projects that are submitted. So, how to apply to those projects? You have first of all to register an account on our database for users. I'm not able to find the... Okay, here, login. Perfect. So clicking on login on the link in the last link on the page, you will be redirected to this web page. This is the UserDB portal that we use to collect all the users that want to use our supercomputers. And here you have to register your username and clicking on HPC access, it will be shown to you all the web form that you have to fill in order to have to ask before to ask for HPC access. After that, you will be able to click on Iskra access and go on the Iskra portal, where you find the link to create a new application. Okay, and then decide if you want to participate to a Class B project or a Class C project. Okay, there is another difference between these two projects. Sorry, I forgot to say that. The Class C projects are always open projects, so calls. So it means that you can participate to a Class C, to ask for a Class C project when you prefer, when you want. Every month we check all the projects that are submitted and provide decide to provide the resources for that project. Class B projects are available only 2 times in a year. Okay, it's possible are open some calls, 2 calls per year. Okay, and this is the first way to obtain resources in our supercomputers from this national project. The second way is to participate to the PRAISE project, that is an European project. We share both HPC resources and knowledge with many other HPC center in Europe. So we provide access to our supercomputers also to every European researcher that work, or it's better to say, every researcher that works in an European institute for research. Okay. The amount of resources that you can ask with this type of project is a higher level compared to the two previous call that I mentioned, the Class B and Class C projects for the ISCRA. Okay. Okay, how to, in that case, you can participate to two types of call. First of all, a preparatory access call that allow you to prepare your project. So, because when you participate to a praise project call, that is a praise project access call, you have to guarantee to be ready to to start to work when the HPC center give you access to the machine. So in order to do that, you can also apply for a preparatory project that allow you to set your, for example, your code to be to obtain the best performance, in order to obtain the best performance from your code working on the machine that you decide to apply for. Okay. Here you can see the machine that are available for the next call. You can see that there are also the two Cineca machine, but this is not updated because Marconi Broadwell system is not available anymore. So, but it's not. Okay. So I think that this is almost all for how to a researcher can ask for HPC access to in Cineca. Okay, for a Cineca supercomputer. So I think that now we can start with the today presentation that is about how to use Python, this new new language compared to other most famous language like C language or Python or Fortran, most used in HPC supercomputers. How to use this new language Python in a supercomputer. So, first of all, why Python? Python is very easy to learn. Is a high-level programming language. It is, of course, powerful. Is an object-oriented programming language. So, object-oriented programming languages provides new features that are very useful for programmers. Python is easy to learn. Python is easy to read because if you try to read a code written in Python, you can see that it's more or less like a pseudocode. So even if you don't know the syntax of Python, probably if you know something about computer science, probably you are able to read the code and understand what it's doing. And it is very, very, very easy to use. First of all, because it is an interpreted language, so you don't need to compile it before to run it. You can directly write the code and run your code. It's very simple to get your program working. There is a phrase that I would like to cite, but I always forgot it, so I prefer to read it. The best performance improvement is the transition from the non-working state to the working state. Okay. This is a phrase from John Osterhout. I don't know if the pronunciation is correct, sorry. Okay. Of course, if you need many time to create a program that is that works, it could be a problem. But with Python, it's very easy to create in quickly working programs. Not only scripts, because okay. Probably you will start to use Python for create scripts, so very small programs, but Python is useful also to create a very complex program with also for scientific purpose. Okay. It is ideal for prototype development. For example, you have your code written in C language or in Fortran, and you want simply to create a new algorithm, a new subroutine, a new function in your program. One thing that you can do is to create a prototype of your new function, new subroutine in Python, just to check if your algorithm is good. Because it's very easy to create new function, new algorithm in Python. After that, you can translate it in your preferred language, compiled language, C, Fortran, C++. Okay. So it is provided also a very large standard library by just after the installation of the Python in interpreter, and it is also easy to extend your libraries simply adding new modules. There are very easy way to do that, using, for example, the pip command to search for you new libraries on the web, on its repository mainly, and take care to install them in the right place and start to use it very quickly. And of course, it's a very good point. This is an open source software. Okay. So we want to use Python in an HPC supercomputer, but everyone knows that Python is slow. So why we want to use Python for in a supercomputer where we need performance? So first of all, it is definitely easy to learn and use. This is a very good point, in my opinion. If you want to start to write a program, this is a very good point to start using Python. If you want to learn computer science, if you want to learn to develop, using Python is a very good starting point, in my opinion. Okay, you can start to practice using Python writing simple script language, and then, for example, writing scripts for pre-process or post-process, for example, to prepare the input of your calculations, so or to elaborate anymore the results from your computation. Okay. But also, it's also possible to accelerate Python. It is slow, yes, of course, because there are. It is slow because there are many features that are extremely useful for programmers, but those features sometimes are time demanding. Okay, so you can accelerate Python. You can use two ways mainly: using scientific modules, for example, NumPy, that is the standard de facto for numerical computations in Python, or using Python combined with other languages. Okay. So, for example, how to accelerate Python using NumPy or combining it with Fortran. So, using F2Py, that is a tool that is provided when you install NumPy library, NumPy module. This feature helps you to create some wrappers that are used to call Fortran subroutines that provided like library to your Python code. And you can call them inside your Python code in the same way you call a function that is present inside a module. Okay, so you can import a Fortran file after the compilation using F2Py, of course, like a standard Python module, and call the function inside this module that are the Fortran subroutines. Yes?
For example, the Fortran subroutine may perform the most demanding computation.
Yes, yes.
And the Python gives you the structure of the code.
Yes, yes. You can use Python for the skeleton of your code, for manage memory, for manage input-output operations. And if you are a Fortran developer, you know that Fortran is terrible on input-output operations, or many other things that are boring. If you want to try to do that in C or Fortran or another compiled language, you can do that in those operations using Python. That is very easy to write code for that purpose. And demand the most intensive part of your code in terms of calculation to other languages like Fortran or C, that are compiled languages, and so they are most give you more performance, so better performance. Okay, another way is to use Cython. Cython is an extension of the Python interpreter. It provides C API, C API for in order to create compiled code that is similar to the C code, but you can create it directly inside your Python code in a Python way. Okay. I don't know very much too much how it works properly. Python I know better F2Py, sorry, but this presentation is just to say to you that they exist. So if you want, if you are a C programmer probably, and you want to use C language to create a program that is with mixed languages, Python and C, probably you can. It's better for you if you take a look on Python. If you are a Fortran programmer, F2Py. Or Numba, also Numba is interesting because it provides something similar to Python. It's possible to compile C code and link it to your Python code, but it provides also tools to link your Python code to CUDA code. Okay, so to use in order to use accelerators like GPUs. Okay. Okay, but today's presentation, today's lesson, don't take care of this way to accelerate Python, but my presentation is focused on this second part of this slide. How to create ad hoc workflows. So, for example, in the way of high throughput computing, for example, the first exercise that we will do is to try to use Python to launch a serial C code that works on many thousands of input files, and to parallelize a Python code that simply is a work dispatcher that take care to launch every the C code, the C serial code on all those thousands of working on all those thousands of input files. Okay. This is the high throughput computing. So when you parallelize a task that is that don't need too many communication between all the tasks that are working. Okay. And then at the end we will see there is not an exercise on that. If you want, you can try to do that, but I will probably we will have time only to see. I will show you how to create a fault tolerance program. That means you have a cluster, you have a reservation in your cluster. For example, the reservation that you are using for the exercise, and you want to run a parallel code written in C or Fortran, compiled language, and you want to be sure that this program will be run many times on many different input files, even if one node of your reservation fall down. Okay, and you have to continue to work. So, first of all, probably it's better to introduce the Python language syntax. I know that many of you already know Python or the basis of Python, but some of you don't know Python, so it is necessary to for this reason to introduce a little bit the language. Okay, it will be a very quick introduction, so I hope in less than 1 hour to stop to conclude this introduction. If you are already expert on Python, probably it's better for you if you go out to take a coffee and back later. Don't worry. Okay, but if you want to refresh your knowledge on Python, it's a good idea also to stay in the class. Okay. Object and type is on Python. Python is a strongly typed and dynamically typed language. What means strongly typed? It means that everything in Python is an object, and every object has a type. I don't have to explain what is a type. Because I'm sure that all of you are already programmers in some other programming language, so every programming language have types, structures, or something like that. Okay. Dynamically typed, that means that your variable can change. It's possible to change the type of your variable. That doesn't mean that you are changing the type of your object, because the object cannot change type. You can simply change the reference of your variable. So the name of your variable is only a name that refers to an object stored in memory. Okay, I would like to write something but it's not possible. Okay, you have to think. I try to explain this in words and without writing it. I hope to be able to do that. I know that. Okay, you for sure you know how it works. How C language or Fortran language manage the access to the memory for the variable that are used by the language. So probably you know that when you define a variable in C or Fortran, what happens is that a specific amount of your memory RAM is reserved, to be used by your variable. Okay, so your variable is a link to the name of your variable is a link to this specific position or specific position in memory. So if you want to change the value of your variable in Fortran or in C, simply you perform an assignment, so like that, a equal 4, okay, and you know that inside the memory reserved for your variable, it is stored the value that you want. And if you want to change it with another value, a equal 5, the new value is stored in the same position. This is different in Python, because if you try to do an assignment like that, it is possible also to change the type of the object that is linked by the or referred, sorry, by your name of your variable, because when you do this assignment, it is created in that moment, because you don't need to declare before the type of your object, of your variable. The declaration is implicit, automatically obtained when you do the assignment. When you do this assignment, it is created an object for that is an integer in memory, and the name A links is a reference, becomes a reference to this object in memory. When you do perform this new assignment, A equal 4.5, what happens is that you are not changing the value in the same object. It is created a new object, and now A is becomes a reference to that new object. Okay. What happens to the previous object, object 4? In Python, there is a so-called garbage collector that check if all the objects stored in memory and if there isn't any more there aren't any more link or reference to that object, the object is deleted. Okay. This is one of the reasons why Python is slow. Also because there is this garbage collector that do these checks. Okay. Okay. So since every object, everything is an object, and every object has a type, you can use the type function to check the type of your object. Okay. So here we are not checking the type of the name A. We are checking the type of the object that is referenced by the name A. Okay. What happens is if you okay, I want to simply not to change this. Sorry, just to be. Sorry, I have to change the okay. Okay. Sorry, just a quick change. Okay, what happens if I perform this operation? B equal A after the first assignment. The first assignment allow me to create okay, Python creates an object with the an integer object with a value of 4,000. Sorry. When I do this assignment, this is not a real assignment, but is a here I'm creating an alias to the same object. So in other languages like Fortran or C, when you have to declare before these two integer variables, A and B. In memory, you have two positions where two different objects, okay, referred by those two names. In Python, you have only one object, the object 4,000, and you have two ways to reach this object, to name this object A and now also B. Okay. What happens if now I change the value of A? A new object is created, and A now is a reference for this new object. Okay, and B B continue to be to refer to the first object. Okay, so I'm not changing the value, also the value of B. Okay. Okay. In order to
Type B would remain an integer.
yes, yes. Type B continue to be an integer. Yes, remain an integer. An interesting thing is also to a good way to check this. If you open the Python interpreter, you can use the function ID to check this. ID returns an integer identification number of your object stored in memory. It is not the address of your object in memory like a C pointer. It is simply an identification number, an index. Just okay. And when you do this assignment, you can check the identification number of A and B and see that they are the same. In Python, there are two types of objects: mutable and immutable objects. Mutable, it means that you can change the values of this object. Okay, change or update your object. Immutable, it means that you cannot modify your object, this object. For example, strings are, or integer, floats, every scalar number is a immutable object. Okay, so when you perform this, for example, if we assign the value of 4,000 to A and then change the value in 5,000, that another integer object, you are not modifying the object. You are creating a new object. Okay? So the first object is immutable. It can be deleted by the garbage collector, of course. Also by you using the del statement, but not modified. You can overwrite an object but not modify it. Exactly. Okay. An immutable object. Okay. Okay. We start to see the first type of object that are strings. Strings can be created using quotes, single or double or triple quotes. For example, with single quotes, home, we create a string that contains the word home, or with double quotes, new home, or with triple quotes. These triple quotes are used to for string that span on over more than one single line. Okay. Inside a string, you can use escape character like /n, /t. That means probably this is a backslash. Yes, sorry, \n. That means it is the characters. If you are C programmer, probably you know. Use for the new line, for change the line inside the string, as \t for the tabulation character. Okay. So using the triple quote, you don't need to add the /n inside your string. Okay, for the new line. Okay, it is possible to perform many operations on strings. For example, it's possible to create a new string with all capital letters all the letters in uppercase using the function upper. What we are doing here? This is the first example on how to use the object-oriented features of the language. An object in object-oriented programming is an object, so is an item, okay, that contains everything needed by the object for everything, for every operation that you can do on this object. It contains many information, and also it contains many information about the object, and also it contains functions called methods of the object that you can use to operate directly on the object. Okay. In that case, how to call these methods simply using the dot operator. So here it means that you are operating on the object A, calling the function upper that operates on the object. Remember that strings are immutable objects. So what happens here is that you are not modifying the string, but you are creating a new string with the operation performed on it. So here we are creating a new string with the same word that we can see in the string A, but in uppercase letters. Another interesting function is the function split. Split is used, of course, to split all the words inside a string. By default, the separation character used is the blank space, okay, white space. If you want, inside the parentheses, you can specify a different character used for the separation. For example, if you are reading a CSV file, probably you know that CSV file, the columns are separated using a comma, or sometimes another character is possible to use, but usually a comma. So you can specify here the comma character in order to separate the elements of a line read from a CSV file. Okay. It is possible to access to single elements or portion of elements in the strings, portion of the strings, using the slicing methods. Inside the more or less like you do, it's better to add one thing. Sorry. Equal. Okay. Perfect. What I'm doing here is simply to access to the third element of my string. Why third? Because the index inside a string starts from 0 to the number of the elements minus 1, like using the C way, not the Fortran way. Okay, to index elements inside a container or something like an array. You can think to this to a string like an array of characters. Okay. Or it's possible, so you can access directly to the single character in that way using the square parentheses. Or you can access to a portion of your string using this notation with the column. This means that you are selecting a portion of your string starting from the index 0, so the first element in that case, to the third element. Okay, the second element, because the second index have to be intended to be excluded. Okay, so pay attention on this. It is possible also to use a negative number. This means that you start to count from right to left, okay? Because by default the index you count the index starting from left to right. It is possible to operate on strings, perform some operation on those strings. For example, the plus sign is not used for sum, of course, but for concatenate two strings. So here I'm creating a new string that contains the phrase my new home is beautiful. Here with the star operator you can concatenate multiple times the same string. So you are adding 3 times the string A. So Python provides some special object, special for people that comes from other languages. When I start to manage, when I started to work with Python, see this, how it is to understand this type of containers. It was very strange for me, thinking at an array that is a static object. I means that is with a fixed number of elements, because lists are special objects in Python that are considered mutable. That means that you can change or update the elements inside a list. You can think to a list more or less like an array. Okay, a sequence of elements stored in memory. We will see later that the difference between an array and a list there are many differences. Okay, we will see later the main important difference. But for now, you have simply to know that you can create a list using the square parentheses, okay, and inside the square parentheses put a list of a sequence of elements separated by a comma. You can create tuples. Tuples are objects similar to lists, but they are immutable. So usually are used to store some constants. Okay, to store some constants. Dictionaries. You can create a dictionary using the curly brackets, and you can see here that every item inside the dictionary is contains a couple of elements. One is a key, the other is a value. We'll see later what it means. You can create also sets that are objects similar to the mathematical sets. Okay, and okay, you can continue. We have not time to see all of those containers. We will focus only on lists and dictionaries. Okay. The first difference between an array and a list is that usually an array has to be homogeneous in the type of the elements of the array. Lists can contain heterogeneous objects. Okay, so you need to create a list, the square parentheses, and inside you can put every element, every Python object that you want. You can index the elements of this list. They start from 0 to the length of the number of the elements minus 1. You can select a single element in that way, and using the square parentheses, the same notation that we have seen for the strings. And now, if you want, you can also modify the value of this element. For example, the first element of the string of the list defined at the beginning of this slide is the number 1, the integer number 1. Here is the integer number 4. You can also change the type. Okay, it's not a problem. Simply, you are putting this position another object. Okay, it is possible also to select portion of the string of a list with the same notation. You can also add another attribute inside this parameter. Okay, inside this notation. Okay, the first parameter means the starting point, the starting index of your portion of list. The second parameter is the final index that is always excluded. And this third parameter is the so-called stride parameter. That is, it is the number of element that you have to jump, use as to jump to obtain the elements that you want.
So K1 is the same as just before.
Yes. Yes.
The first,
yes. If you the default is, of course, if you omit this element, the default is 1. Of course, so you are taking all the elements, contiguous elements. So if you put here 2, you are selecting one element, jumping 1, selecting another one, and so on. It is possible to concatenate 2 strings and also to concatenate using the plus operator. Yes, just one moment. And also to concatenate 2 portions of your string. What we are doing here is to swap, is a way to swap 2 portions of a string. Okay, so we are selecting the last element of the string and putting at the end, at the beginning of the list, creating a new list in that way. Okay, so swapping some portion of the element. Yes. So
we should go for the coffee break.
okay. Yeah. Yes. Okay. I think that we can stop here. Yes, it's not a problem. It is only an introduction. We'll see later in how many minutes? When you, okay, when the class is another time full, we can start. Okay.
Lo spegniamo.
Ah, giusto. Bene. Da chi a casa, da chi in remoto, se sentono bene? Non vorrei che la barba copra il microfono. Okay. If you're ready, we can continue with the presentation and with the introduction to the Python language. So we are talking about the lists. Lists are containers, so-called containers in Python. List can contain elements, heterogeneous elements. That means that you can put inside a list Python object of different types. You can select single elements and eventually modifying them because lists are mutable objects. You can select portion of the list in the same way we select portion of strings. This is a interesting way how to swap two portions of a list, taking the right portion and swapping it with a left portion. Okay. So, since you can modify the elements, you can also update your list adding new elements. For example, using the append method of the list. The append method takes only one argument, and the argument is added to the list at the end of the list, at the right of the list. You can use the pop function, the pop method, to remove the last element of a list, and the result of this function returns the last element of the list and remove it from the list. So you can use a list like a stack. I think that I don't need to explain you what is a stack in programming language, in computer science. So to create a new list, one of the most used ways is to use the range function. Pay attention, there is a difference between Python 2 and Python 3. Both are two branches of Python. The branch Python 2 is a so-called death branch. That means that it's not anymore upgraded, but it is it continues to exist because there are many software already developed in Python 2. So it is I think I say that it's a dead branch, but in practice it is very live. Okay. Python. So there are some difference between Python 3 and Python 2. Okay. The range function in Python 2 returns a list directly. Okay. Returns a list of integer numbers starting from 0 to the number used as argument minus 1. Okay. Or you can use the range function to create specify the starting point of your integer sequence, the final point -1, and the stride parameter also. In Python 3, the function range returns not a list but a sequence. A sequence in Python is an object that you can iterate on. You can scroll on this object element by element from left to right. But all the elements of this object are not stored in memory. You can access to them one by one when you need a specific element. Okay. So that means that this object contains the algorithm that allow you to iterate on this sequence, okay, and to provide to the user every single element one by one without storing all the elements in the memory. Okay. Instead, a list is an object. Is a container. You can iterate on this object. You can scroll on all the elements of this object, but all the elements are stored in memory. Okay. So the function range in Python 3 in particular, but also in Python 2, but in particular in Python 3, the function range is very is used mainly associated with the for loops. Okay, we will see later a slide about that. Okay. Okay, now we can see the dictionaries. They are used to map two types of elements. Some elements used as key and other elements used as value. Inside the dictionary, you can find that every item of the dictionary is composed by two elements, and you can see here how to write an item. At the left of the column there is the key of the item. At the right of the column there is the value associated to this specific key. Okay, so you can access to the single item you can access to a value of an item simply using the key of the item, okay, instead of using the index, the integer index, like you do when you want to access to an element of a list, for example. Okay. So you cannot specify an integer number, an index, to access to a try to access to a specific element or specific item, value of an item in a dictionary. In particular, because also because dictionaries are not ordered containers. So the order inside the containers is not guaranteed by Python. So Python decides how to sort the items inside the dictionary. Okay. For example, if all the keys are strings, usually Python decides to order the items inside the dictionary in alphabetical order using the keys, usually. But this is not guaranteed. Okay. Okay. Dictionary are mutable objects, so it means that you can modify an item, so the values associated to a key. Another important thing, the key have to be unique. So it means that you cannot have inside the dictionary two identical keys. Okay. Another important things. You can use as key every type of immutable object. Okay, so you can use as key a string, an integer, a float, a complex number, because Python provides also complex types. A tuple. A tuple is something similar to a list but immutable. Okay. But you cannot use for your keys a list, because a list is a mutable object. As value, you can use every Python object, both the built-in object or the user-defined new objects. Okay. There are some functions that you can use to obtain a sequence of all the keys, or a sequence of all the values, or a sequence of all the items of the object. The sequence of items, the elements of this sequence are tuples with two elements. The first element is the key, and the second element is the value associated to the keys. Okay, control statements. We can see here the classical example of a if-else statement. Okay, pay attention, because in Python indentation matters. Every one of you, I think, know that it's a good idea, is a good practice to use the indentation in your when you write a code, because it is more readable. In Python, it is mandatory, because you define the body of, for example, the if instruction using the indentation. You can see here. Okay. Okay, you can see this as in this example. You can use, of course, the if keyword to start the if instruction. After the if, you can put conditional expression. That means that this is a condition. This is a Boolean expression that returns a Boolean value. That means or true or false. And after the conditional expression, there is a column at the end of the line. That means Python knows that that means that you are starting from the next line the body of the if instruction. And in order to put a statement inside this body, the blocks of instruction related to this if statement, you have to properly indent the instruction, the statements. So this print A is inside the body of this if, and also this other print is inside the same body, because we can see the indentation is the same. Now we stop to the indentation with the elif instruction. that means that the body of the if instruction is closed. Okay, so we don't have in Python character used to start or stop a body like in C that you can use, where you can use the curly brackets, okay, or in Fortran that use the end statement to stop a block, and so on. Here, I think that you, every one of you knows what is an algorithm, a statement if, what means else, what means elif. Okay, I don't need, I think, to explain that. So, simply, the first condition that returns a true value, it is used to run the associated block of instruction, the body of instruction. If all the conditions are false, the block of instruction related to the else is executed. Okay. Okay. About the for loop, also for the for loop you have to take care about the indentation. Okay. How many spaces used for the indentations? You can choose. You can also use only one space, 2 spaces, 3 spaces. For in the documentation website of a Python documentation website, it is suggested to use 4 spaces. So I usually use 4 spaces. Okay. But don't use the tabulation, the tab key to for the spaces, because for indent, because some version of Python are not able to recognize very well this the tabulation. Okay, so it's better to use 4 spaces, or the number of spaces that you need. Eventually, I think all the newer editors, you can specify to the editor to substitute real spaces when you press the tab command. Okay, to select, for example, I like to write code in Emacs, and it is possible to specify in the Emacs configuration that when I press the tab key, it will be it is substituted with 4 spaces. Okay, simple. Okay. Here, how to use what is used for the for loop? The for loop is used to iterate on sequences or containers. For example, you can iterate on the sequence returned by the function range. So that means this sequence is composed by the number 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, sorry, not 5. And so here the body of this for loop is simply the statement print I. Sorry, another thing, okay. Look here. Here I'm using the print as a statement, and here I'm using the print like a function. Okay. What is the difference? This is the Python 2-way, and this is the Python 3-way. Okay. In Python, this is another difference between Python 2 and Python 3. Sorry, I forgot to modify all the slides. So pay attention in Python 2. Sorry, the print is a statement, so you don't need the parentheses. In Python 3 is a function, so you need the parentheses. Okay. So you can also iterate on containers like strings using the for loop. So the I in that case is the iteration variable that iterates in a list, used for iterate in a list. Okay. So here we are printing all the elements of the list. Inside the for loop and also inside a while loop, in that slide there are there is an example of the while loop. A while loop is simply use the keyword while and then and a condition, then the columns and the body of the instructions. Inside the for and while loop, you can use the instruction break to exit from the loop. Usually the break instruction is put inside the body of an if statement. Okay. Or there is also the possibility to use the statement continue, jump to the next step of the loop, simply. Stop to execute the part of the body after the continue and jump directly to the next step. Break, exit to the loop, continue the loop but jump it to the next step. Okay. There is an implicit translation, conversion of all the built-in Python objects to a Boolean value. So when you use the Python object inside a condition, you can also use them as Boolean values. For example, an integer with value 0 is considered like is converted like a false value. Okay. So if you write if 0 is like to write if false. Okay. An integer different, not 0, is a true value. A float equals 0.0 is a false value, is converted to a false value. A float different to 0.0 is true. An empty string is false, otherwise is true. An empty sequence or an empty container is false, otherwise is true. Take care of this because we will use this feature in one of our exercises. Okay. There are two ways to manage input-output operation on files. There is the old style. Please, never use this old style. I simply show you because it's possible that you can find some, read some old Python code that it is using this old style. It's better to use this new style because it's stronger. Why it is stronger? Okay. First of all, I described the old style. To open a file, you have to use the open function. The first argument of the open function is the name, is a string containing the name or the complete path of a file. The second argument is a character, a string or a single character, indicating the mode that you want to use to open the file. R stay for reading mode. R, sorry, stay for reading mode. W stay for writing mode. The letter A stay for append mode. Because if you open in writing mode an existing file, you overwrite the file. If you don't want to overwrite the file, you can open it in the appending mode. So the cursor of the file is scrolled to the end of the file. So you continue to write inside the file from the end. It is possible to operate after you the result, the returns of the open file is a file object, because everything in Python is an object, so also the files are objects. So we need a file object, and we give the name, in that case f, to the file object, so we can use this name to operate on the file. In that case we are reading all the lines of the file. You can see here that this function read all the lines because there is the final s. If there is also the function readLine, okay, that read only one line. After all the operation performed on the file, you have to remember to close the file in that way. With the new style, you have to use the with block of operations. The with statement is used in this way. You open the file using the with statement and give a name to the file. You can see here that at the end of the line there is a column. That means that we are opening a block of instruction, a body of the statement with. Inside the body you can perform all the operation that you need on the file. For example, in that case we have opened the file in writing mode, so we can write, using the write function, something on the file. Pay attention, I forgot to say to you, the print statement or the print function at the end always add a new line character. Okay, so it is a thing that you have to know when you write code, write your output. Okay, the write function don't add this by default, so you have to add it if you want to change line. Okay, so pay attention to this simply. Okay, as you can see here, there isn't you are not closing the file. You don't need to do that because the with statement, the with block, take care to do that for you. Why? It is a stronger way to use this method instead of the previous one. Because if your program crash when you are doing some operation on a file, the with statement take care to close the file in a safe mode, for you. Also if also when your program is crashing. So before to stop the program, the file is closed in a safe mode. This is useful if you don't want to corrupt a file that you were reading, for example. Okay. It is possible also to iterate on a file. The f object, the file object, is an object similar to a container, and the elements of the file object are the line of the file. of course, this is true for a text file. Okay. I think that for a binary file you can define some records or something like that. I don't know exactly. Okay. Okay. The operation, the iteration is used the for loop. In that case, I use of course the as iteration variable a name that is comprehensible for me and for another person that wants to read my code. What I'm doing, I'm iterating on all the line of the file. Okay, and in that case, what I'm doing is appending all the line to a list that I can use later. Okay, that store all the, for example, all the variable of my input file. Okay, all the parameters of my input file. What is this strip function? Is an interesting function that you can use to operate on strings, because the line is read and it is translated to a string, of course. Strip delete from the left and right of your string all the escape characters and all the white spaces. Okay, but only from the left and the right, not the spaces inside the string. Okay. How to define a function in Python? You have to use the keyword def, the name of the function, and between the two round parentheses, a list of arguments. At the end, the column that states that we are initializing the body of the function. An interesting thing that you can add to a function is a string without any type of associator. Sorry. If you put a string in the line below the name of the function, this string is called docstring, and it is used for documentation. Okay. There is a function called help that you can use in interactive mode in Python. If you use this Python and ask help for a function, both a built-in function or a function developed by you, in the output there is also of the help function, there is also the description that you added here. In this description, you can also add an example on how to use the function with some value as arguments and a result. If you do that, you can use a very interesting tool, an external tool, that you can launch this tool that read a Python file containing many functions. All that function have this description with an example. The tool, PyDoc, no, PyTest, I think the name, I don't remember very well. So PyTest, check, run the function with the same value that are present in your example, and check if the result is correct. So you can use this interesting tool when you want to change the algorithm of an already existing function. So if after the test the results are all okay, continue to be the same, okay, perfect. But if you obtain some not expected results, probably you have introduced some bug inside your function. Okay, so it's very interesting. So please, I suggest to you, if you start to develop seriously in Python, to always write a docstring and always put in the docstring an example on how to use the function. Okay, here to return a value you have to use the keyword return. After the return you can put a single value or an expression that returns a value. Pay attention that a function returns always one object. If you need to return many values, you can collect all these values inside a container and then return the container, for example, a list. So you are returning only one object, a list that contains many elements, many values. Okay. How to call a function? Simply with the name and the list of the arguments. Okay. It is possible also to use default values for the arguments. In that case, you can, for example, right here. If you put, if you write this, okay. This means that for you the default value for B is 1, so you can launch also the function in that way. So what happens in that case that it is performed the sum between 4 and 1. Okay. Ah, sì. Thank you. Okay. Okay, what is a module in Python? You can consider a module more or less like a library in other languages. Okay. Every file containing every file with an extension .py containing Python code can be used as a module in Python. When you start to write code in Python, it's a very good idea, it's a good practice to write code to use okay, I'm not able to, I will show you in the first example later. To use the variable underscore name underscore is a special variable. Since everything in Python is an object, every object contains many information about the object. Also a variable containing its name. Inside the name variable, there is a string with the name of the object, and the name of a module is the name of the file without the extension. Okay, but this is what happens when you want to import a module in your program. So when you want to add a library to your program, okay, the name of the module is the name of the file without the extension .py. If you launch a program, because your module, your library, could be also launched like a normal program, okay, the name of the program is not the name of the file, but it is a string containing underscore underscore main underscore underscore. This is because you in that way you can understand if your file it is launched as a program or it is imported as a module. Okay, and we will say later in the first exercise how to use this. Okay, this. Now, how to use a module? Here, this is the cut of a file named fibo.py that contains only one function. The function fib that requires only one argument, an integer number, and returns, of course, a Fibonacci series up to the number n. Okay. Okay. How to use is not important to see the algorithm that we are using. Probably it's too simple. It's very simple just to be able to write the algorithm inside a slide. Okay. So how to use this module in your program? You have to first of all import the module with the import keyword and the name of the file without the extension, and in that way you can use the fib function operating on the fib module. Okay, that means to use the fib function you have to specify the path, more or less, okay, that you need to reach the position of the fib. So you are saying here that the fib function is inside the module. So this is, so Python know where to find the function. Okay. Okay, how to use the command line arguments in Python. This is another program file called myprog, myprog.py. Okay, the first line of this program file is the import of the sys module. Python provides to you many modules that are available just after the installation. Those modules are the standard library of Python. Okay, the sys module is used to collect many tools, many features that help you to communicate with your operating system, of course. In that case, we use the sys module because inside the sys module there is a list called argv that contains as first element the name of the file, of the program file, and as and from the second element there is the list of all the arguments passed to the executable by the command line. Okay. So in that case, what I do here is check the length of this list. If it is less than 2, it means that we have not put any arguments on the command line. So it is printed the usage of this program file, and the body of the program file is very simple. Simply iterate on this list, starting from the second element to the end of the list, printing on all the arguments all the command line arguments one by one. Okay. You can see here that we are launching the program file using the Python interpreter, Python executable, the name of the program file, and some arguments that are printed in that way. If I forgot to add the arguments, it is printed the usage. Okay. This is not the best way to use the arguments in Python from the command line. This is the most simpler way, the one that is the default way. But you can use also another module that is provided with the standard library, argparse, that help you to parse the list of arguments and create also some flags, like the flags that you can use usually in some Linux commands. So, for example, -o for the output file, or -e for the input file, and so on. Okay. So you can this module help you to create those flags and to manage them.
Sorry, what is this model?
Argparse. Later, if you want, I can give you the link of the presentation that I usually do when in the Python course in Cineca. There is also one of the presentations, because it is split in many presentations. Of course, the whole course is split in many presentations. One of the presentation is on the most used modules of the Python library, standard library. Okay, and there is also the argparse. For every module, there is only a single example. It's not a complete instruction how to use all those modules, but it's a list of all the most used modules that probably sooner or later you will need to use if you continue to develop in Python, and a simple one or two example on how to use them. I think this is the last slide about the introduction in Python. This is not a basic information about Python. This is a little bit more advanced information, but we need this in our exercise, so it's better that I show you this. In the standard library of Python, there is also the module subprocess. That is, inside this module, there is the object popen that is used. It is a constructor that executes a child program in a new process. So it is used to launch an executable from inside Python. Okay, it is created a new process, and inside this new process, it is launched the a child process. Sorry. And inside this child process, it is launched an executable. How to use it? Here I'm creating a command line. Okay. In this case, my command line, the executable that I want to launch. Okay, the name of the executable is executable. There are some flags that he needs, -e and the name of an input file, -o and the name of an output file. The first argument of the function popen have to be a list. Okay. So how to create a list from a string using the split function that splits all the words inside a string and put them inside a list, and all the elements of this list are the words of the string. Pay attention because the first argument have to be a list, and every element of the list have to be a string of only one word without spaces. Okay, it is mandatory. I don't know why, but not so difficult to provide this, so it's not a problem. So popen accepts many other arguments. Some of those are all of those are not mandatory, so are oh my god. I hate when I forgot the words. Okay, not mandatory. In this case, I'm using only this argument. Okay, now all the arguments, all the other arguments have some default values. This is what I want to say. Okay, I'm using now this std out argument just to put the output, to redirect the output of my executable inside a standard output file, an output file that I opened before. Okay, so probably this command have to be launched inside a with statement. Okay, the results of this function, it returns an object that is my child process, and I can operate on it. For example, saying that I want to wait and stop all the other execution until this process is completed. I can use this communicate just to take the output and error output the output error of this from this process. I can kill it. I can use this argument this variable to check the identification number of this process and so on. I don't remember what pull do, but okay. Ok, è previsto un'altra pausa? No. Che ne sono? Okay. Before to start to see this other part of the presentation that explain to you how to use MPI for Pi, that is a module for Python, I want to show you the Python executable, a Python script that manage a workflow of serial executions that we will parallelize later. Okay, so I use now. Sorry. Okay. In the page where we put all the presentations there is also a tar file containing all the file that you need for the hands-on. Inside there are also there are already the solutions. So don't. If you want, you can check them, but it's better for you if you start to do the exercise and then use the solution just to check if you are doing. Yes. Okay. And this tar file contains the same files that are present also in this at this link. Okay. Okay. In particular, we start with. Oh, there is also a README file that explains to you all you have to do in this exercise. In all the exercise that we will do in the afternoon. First of all, I want to show you the serial Python program that we want to parallelize. This is a Python program, and you can see that because there is the extension .py, of course, but you don't need it. You can write a Python program and you don't need to put the extension .py, but it could be a good practice to do that just to to better understand what it is. Okay, this Python can be launched both using the interpreter Python 2 and Python 3. It's not a problem. For the exercise, we will use Python 2 only because the module MPI4Py in our cluster, it was installed using Python 2. So, just for this reason. At the beginning of this file, you can see that are imported some modules. There is the import of the OS module. Also, this module is used to interact with the operating system. The sys module that we have already seen before. Glob module, it is used to create a list of files. It is used here, we will see later. Time module used for we will use it for the timing inside the program, just to check the performance, of course. And the subprocess module, and we need from this module only the function popen. So this is another way to import something in Python. If you don't need all the module, all the stuff inside the module, you can decide to import only the function or the variable that you need. This is the way. From the name of the module, import, and the list of the stuff that you want to import. Okay, here there are two, the definition of two functions, and here there is the main of the Python program. Okay, you know, if you are a C programmer, that you need a main function that is the first function that it is executed when you launch a C program. Or if you are a Fortran programmer, you know that there is the procedure program that is the first procedure that is executed when we launch a program in Fortran. In Python, there isn't something like that, okay? Because in Python, every single file of your program can be used as module or as a program file directly, okay? In order to create something that is similar to the C or Fortran way, it is used this if statement, okay? This means if the variable name, the special variable underscore name underscore is equal, so the values is the same of this string underscore main underscore main, that means if this condition is true, it means that we are launching the program directly from the Python interpreter, okay? If this is so, and inside the body of this if, we can put all the instructions that are related to the main part, part of my program, okay? So usually when you create a new program or you want to create a new module that have to be used as a library, you always have to use this if statement. Before this if statement, you can put the list of all your functions, and after in the body of this if you are developing a library, you can put many instructions, for example, many examples on how to use the function. So you can use this module directly, the same module, both as library, the same file, both as library and as a program test, to test the library, okay? You understand what I mean? If not, you can say it. Don't worry. Okay, so we start to before to read this file. We start from the main, and then we look what the function do. So, oops. Okay. First of all, I'm creating a variable named executable that will contain the first argument from the command line, okay? And another variable called input_dir containing the second argument from the command line, okay? Because as explained here in this string, because also the modules can have docstrings, okay? So if you put a string as first line in your program, in your program file, this is used as a docstring, a string for the documentation. So how I want that this program is used. Launch. You have to launch the program, serial q.py, add a first argument that have to be the executable that you want to use, and a second argument that is a directory containing all the input files. They have to be executed by the executable, okay? So now I'm creating a program. I created this program that take care of to take the executable, launch the executable operating on the first input file. Wait until the end of the executions, then launch the same executable on the second input file, and so on. We want to execute in the example that we will do later, 3,000 input files. Of course, don't worry, the input files simply need less than 1 second to be executed, so don't worry. Okay. After that, here I'm creating a list. And I name this list inputs, of course, because this is a list containing the path of all the input files. Because how to do that? Calling the function input files that takes as only arguments the input directory. Inside the input files function, I call the glob module that create the list of input files. As you can see here, the glob module is able also to understand the wildcards. Okay, so understand that what I want to do is to read all the file, to select all the files that start with the name input, then there is something else, and with the extension, the final extension .txt. Instead of this star, of course, there will be an integer number, simply just to enumerate all the input files. Okay. After that, here I simply print the number of elaborations here. Then I call the first time the time function, run the launch the run function, and then after that I call another time the time function. That's to check the performance of this code. Okay, what the run function do is iterating on the list of input files and launching, creating a new sub-process, a child process for every input file, and launching in this sub-process the executable that operates on the input file. Okay. Here I'm using the list containing the name of the executable and the path of the input file. And the output is redirected to the out file. Out file is created here as the same name of the input file plus the extension .out. Okay. Before the ending of the step of the loop, I wait that the process complete the execution. Okay, the child process complete the execution. Okay, this is the explanation of the serial Python program that we want to parallelize. So before to do that, we have to create the input files. In order to do that, I created a script. Where it is? Get inputs. That is a very simple script that create all the input files located inside a directory first of all, create a directory named inputs. Then inside this inputs directory, create many files named inputs a number.txt. Inside of these files, puts a random number from 0 to 1 that are the seconds that are weighted by our serial C program. Simply so, the simulation that we want to do now is that. Okay, our C program is this is the serial program that we want to launch, and this is a C program. What it does is simply wait the seconds written in the input file before to exit. Okay. Yes.
On the file single underscore q.
Yes.
When we call the function run executable,
Yes.
it takes all the input files from the input list, let's say, and then
Yes.
open the output file, taking the name of the input file plus dot out.
Yes.
But in this way, it will be like I don't know if I understand. Like input 01.txt dot
Yeah.
out.
Yes.
So
See, we are simply adding another extension.
now,
Yes.
so
So
basically we could also
yes.
subtract the .txt.
Yes. 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 It's possible to, for example, as said Mirko. Now we can strip
Okay.
the extension .txt, or simply if we know, we are sure that the extension will be always forever .txt simply, and we know that those are 4 characters, we can select the sub-portion of a portion of the string from the beginning of the name of the file from the beginning until to before the last 4 excluding the last 4 characters. So for example, no, okay, no, I cannot change. Okay, directly. Okay. So in order to do that, you have to download all those. I think that me too. I have to do. Oh no. I don't know why I'm doing that. Ta-ta-ta-ta. The cluster that we have to use Galileo. Yes, okay, perfect. So sorry, I forgot to copy the tar file on the machine. I don't know why. Sorry. Ok. C'era un... Okay, sorry for the late. Okay. Here, so first of all, we have to create the directory containing the input files. So we can simply launch. It's better if we to read the README file that explains to you what you have to do step by step. Okay, so first of all, you have to load the Python module. Also, I prefer to read it because sometimes happen that I forgot some steps. So it's better. It's a good idea also for me. So module, load the Python module already provided on the machine. So for this selection, as I said before, we have to use Python 2 only because the installation of MPI for Python, MPI for Py, that I know works very well, is the one installed with Python 2. There is another version of MPI for Py installed with the Python 3. It's a newer version of MPI for Py, but I know there are some bugs. So it's better to not use it right now. So, but so we are using an old version of MPI for Py, but for this exercise, it's okay. It's not a problem. Okay. After that, we can launch the getinit.py program and passing as argument 3000. That means that I want to create 3000 input files. And as you can see now, there is the input directory. Inside the inputs directory, there are, okay, starting from the number, well, 0000 to the number 2999. Okay, so 3000 of files. We can check only one of those just to see that. Oh, sorry, forgot the S. Okay. You can see that inside there is only one line, and the first element is the number of the second that to be weighted by the serial program written in C. So, just because I suppose that we need some minutes, many minutes, to execute all those input files, I think it's better to launch now the serial file. I continue with the presentation, and then later we check how many times we need to execute all these input files. Okay, so cat readme just to continue with. Okay, so now I need to load the Intel module because I need to compile the C program. Okay, and to compile the program, we use ICC compiler, the Intel compiler of the C language. without any optimization. We don't need it, of course. Okay, so we can see that there is the executable serial program .x. Okay. Are you able to read also in the last line? Are you in the last row? So okay. Okay. So after that, so we have to, but a good idea to change the permission to the all the Python files. We want that to execute them, so we need to give them the permission to be executed. Sorry. So now we can see that all the Python file, fault tolerance, master slave, multiple queue, single queue are okay. Your starting file is single queue.py. The solutions are the multiple queue file, master slave .py file. So don't look at them now. Of course I have already provided the solution, but don't do it. Okay. So now I need to check the job launcher. I prepared also the script, the batch script to launch the serial program. I need your help. Those information are correct? Account train underscore train to 18 reservations. Not the reservation, without the reservation. Okay, so I can. Okay. Don't need that. So in the bash script there are all the lines that have not to be executed now are commented, of course, but they are ready to be decommented to be launched later. Okay, so for now I think these should be good. 1 hour is enough. And we can launch.
The random time was between 0 and 1.
Yes.
So
Yes. At least
3,000 seconds.
Yes.
Worst case,
Exactly.
except for the overhead times.
Okay. So it's less than 1 hour. Wow, so perfect. Yes. Okay. We can launch.
You should complete in half an hour.
Sorry.
If they are
Yes.
uniformly distributed.
If it is not complete in 1 hour, probably there are some problems. Okay. I check. Yes, it's running. Perfect. We can check if it is working with ls inputs. No? Okay. For now, only 19 yes, of the outputs are or of the inputs are executed. So, okay. So it's working. Now we can continue. What time we have to stop for the lunch?
Half an hour, about half an hour.
Okay, perfect. MPI for Pi. Devo stare attento quando mi alzo dalla sedia. Yes. Ah, okay, yes. I use the WC command to check the number of line of the of this command. So usually, yes. Okay. Ah, okay. Better? Okay. Well, okay, the presentation. Can continue with the presentation about MPI for Pi. No, okay, MPI for Pi. MPI for Pi is so what we want to do. Why we want to use MPI for Pi? Okay, now we usually the philosophy behind what this presentation is that use only usually often only a small portion of the code is time critical. Okay, so we want to use Python for everything apart from heavy work calculation. Okay, so we use Python to manage memory, input-output operations, user interface, error handling, and so on. Okay. For parallelize our code, serial Python code, we will use MPI for Pi. MPI for Pi is a MPI, of course, for Python. Is a module that provides binding to the message passing interface to MPI standard library. Okay. For the Python language, of course. Okay, the newer version of MPI for Pi is constructed on top of the version 1, 2, and 3 of the standard of the MPI standard. Okay, so provide I don't know if all the features of MPI 3, but probably almost all the features. Okay. The main interesting things is that this module provides an object-oriented interface for MPI, similar to the one provided in for the MPI 2 version for the C++ language. Okay. So if some of you already used MPI on C++, probably is able to recognize many of these way of use MPI on Python. Okay. With MPI for Pi, it's possible to communicate any built-in or user-defined Python object. Okay. Under the hood, MPI for Pi is using the pickle module because probably you know from the previous lesson in the lesson on MPI in the previous days that it is possible to communicate only continuous portion of memory, buffer of continuous portion of memory. Okay. But the Python object, some Python objects are not continuous stored in memory in a continuous portions of the memory. So to solve this problem, it is used the pickle module that create a binary representation of your object stored in a continuous portion of your memory and used as buffer that is communicated to another process. The other process, after receiving this the buffer, restore the object and use the object. Of course, this procedure can be very slow for two reasons. The first, we are duplicating our data in memory, and second, so we need to use more space in memory, and second, you have to copy it, so we take time to do this copy, to create this new object before to send it, to communicate it. But it is possible also to communicate continuous portion of your memory, continuous buffers, using, for example, NumPy arrays. NumPy is a numerical module for Python. It is, as I already said, the standard de facto for numerical computation in Python. NumPy provides a special structure that is called ND array that are exactly equal to under the hood of this ND array there are C arrays written in C language. Okay, so they are exactly the same things of C arrays that are stored in memory in a continuous way. Okay, continuously. Using NumPy arrays, you can reach the performance of a Python code, MPI code written in C. Okay, but in this presentation we don't want to use, we don't want to send arrays. Okay, in the exercise that we will do in the afternoon, we want simply to send information about, for example, the input file, the input location, the location of the input file, or something like that. So we want to communicate Python objects, in that case strings. So it's not a problem if it is a little bit slower, because we are sending very small objects, so it's not time demanding. Okay. Okay. So it's very important. You have to you can send communicate Python objects only if they are very small, and you need this type of object for all your process. Okay. So this is the explanation of why sending, for example, a list could be very, very slow in Python, a Python list, because okay, this is a NumPy array. Okay, the data of the NumPy array, so the single elements of the values of the single elements of the array are stored in memory in a continuous way. Okay, like the data in a C array. Of course, the NumPy array contains also other information, but the most important information are the data of the values of the elements. The items of a list are not stored continuously in memory. They are put more or less randomly inside the memory. You have only a continuous list of address in memory, so you can just to know where the items are located inside the memory. Okay, you need this structure if you want to have a mutable object, of course. The features of this mutable object are useful if you want to easily operate adding, subtracting elements on this object, but are not useful when you want to send this object to another process. Okay, but of course they are not built to this purpose. Okay, so how to use MPI for Pi? First of all, you have to import the module. Well, from the module MPI for Pi, you have to import a special object called MPI. Okay, this MPI object contains information about the communicators and all the functions needed for the communications. Okay. You don't need in a Python program use MPI to initialize the MPI environment. So you don't have to call MPI init, for example, because when you load the module, you import, sorry, the MPI object, automatically this import call the MPI init and initialize the MPI environment. And also you don't need to finalize, because at the end of the program Python take care to finalize the MPI environment. Okay, so don't need to initialize and finalize in your program. You have only to load the MPI, to import the MPI object and use it. Inside the MPI object is already present the ComWord communicator. It is the communicator. I don't have, I think, to explain another time what is a communicator. You already know, I think. Okay. The ComWord is the communicator used to communicate with all the process that you are using. Okay. How to obtain the rank, the identification number of your process? Calling the getRank method that is already present inside the communication ComWord. Okay. So here I'm creating an alias com that refers to this object ComWord. Okay, and using this alias to call the function inside the ComWord object. Also, this is an object in Python. How to obtain the size, the number of processes in this communicator, simply calling the getSize function. Okay, so those are very simple instructions that you probably already know the meaning of them. So we can continue. We can see directly some point-to-point communications. Pay attention on how to decide what is the function that you have to use. It is different if you want to communicate Python object or buffer, continuous buffer objects. For example, NumPy array. Okay. If you want to communicate a continuous memory buffer, you have to use functions with the first capital letter, okay, uppercase letter. The function with all the lowercase letters are used to communicate Python objects. For example, list, integers, single integers. Okay. Of course, in this example, you can see only blocking communication, but are available also non-blocking communications. Here a first example of a Python code that performs a simple, very simple communication, two very simple communications. In this code, MPI code, we want to use only two processes, the process with rank 0 and the process with rank 1, okay? Rank 0 sends something to rank 1 and wait for receiving something from the rank 1 and vice versa, okay, for the rank 1. So, first of all, you have to import the MPI object from the MPI4Py module. Call the three, execute the three statements we have already seen just to obtain the rank, the size that we need for the other part of the code. Inside this block statement, this if statement, under the condition that rank is equal 0, only the rank 0 send a list. In that case, the first argument is the buffer that we want to send. Okay, the object, sorry, not the buffer, but better to say this object that we want to send. And here I'm sending a list of 3 elements containing the rank, 10 plus rank, and 100 plus rank, simply. Okay, so that means 0, 10, 100. I have to specify the destination process and a tag number, integer number. Then, after the sending, okay, in the other block, under the else statement, the rank 1 receive the object and store it in a variable called buff. Receive from the source equal 0, from the rank 0, using the tag equal 10. Okay. So, if you remember the prototypes of the function, used in C or in Fortran, inside the arguments you have to put also information about the communicator that you want to use, or the type of object that you want to, of type of element that you want to send, the number of elements that you want to send. All those information are not necessary in that case, because Python try to catch them automatically. Okay. In particular, where is the information about the communicator? This is a very important information.
You find understand at the start of the script.
Sorry? Yes, but where in the send function, where is the information about the communicator? It's not present here.
Yeah, but you are creating.
Yes. Okay. You are sending. You are using the send function contained inside the communicator itself. Okay. It's a method of the communicator. This is very different between the way that used on C or Fortran. Okay, in C or Fortran, the communicator is simply an integer number, nothing more. Okay. Here is a more sophisticated object. Okay, and then after the sending and receiving from the other process, it is performed an opposite communication. Okay, simply, very simple. Perfect. At the end, it is printed the rank of every process and the data received from. I received. Okay, the data received and so on. Okay, here another example on how to communicate NumPy arrays. Okay. First of all, there are two examples, two ways to communicate NumPy arrays. The first is the one where you are explicitly specifying the type of the type of the element contained in the NumPy array. I forgot to say before, a NumPy array has to be an array containing elements of the same type, like a classical C or Fortran array. Okay. So in this case, here I'm creating an array with 1000 integer elements, and data is the buffer that I want to send, and MPI int is the type of the elements. Okay, and here the same for the receive function. Take care, I'm sending and receiving using the function with the first uppercase letter. Okay. In the other example, we are doing the same, more or less the same things, but we leave the Python or the MPI for Py to discover automatically the type of the data. So here you can see we are sending directly the data. Okay. Before we have put inside a list the data and the type. Here we are sending directly the data. Okay. Okay. Two interesting not arguments, sorry, attributes contained inside, or objects contained inside the MPI object, okay, are MPI any tag and MPI any source object. How to use MPI any tag? You usually want to use MPI any tag when you are receiving a message and you don't care the tag that is used to sending this message. You only know this, the identification number, the rank of the source process, of the rank of the process that send the message, but you don't care about the tag used. Okay. MPI any source, it is used when you know exactly the tag, but you don't care who is sending to you the information. Okay, so you are here, you are waiting for receive a message from any source with the tag 20. Okay, you have seen this also in C or Fortran. You have it was explained to you in the MPI lesson. Yes. Okay. Perfect.
I'm sorry.
Yes.
If I have more than 2 tasks, at the end, path will be just one string, one list of 3 integers, but I don't know which one exactly, because I don't know which task.
Yes. Yes. But you can use this object MPI status to check the information about the receiving message. So you can create an object and call it status using the function status that is a method of the MPI. Sorry, I'm not sure. Probably there is an error here. If I remember well, the first is have to be a capital letter. Sorry, I'm not sure. We can check later. Okay. It is very important because Python is case sensitive, of course. Okay. And you can put this object as argument under this argument name status. Status equals status. Okay. So after the receiving after you the process receive the message, you can check the information about the received message. Checking using the function contained inside the status object. So get tag to obtain the tag used in the message. Okay. So if you use MPI any tag at the end of the communication, you don't know the tag, so you can check it after. Okay. Or you can count how many elements are have to be communicated. Have been communicated. Sorry. Count how many elements are contained inside a data type MPI data structure. I don't know if you have seen that. Is a little bit complicated things. It's a more advanced MPI. Probably you didn't see that, so don't worry. You can check if there are some errors on the communication. You can check the source because if you use MPI any source, you don't know who sent to you the message, so you can check it. And there are also other functions contained inside the status object, but those are the most used. Of course, you can also perform collective communications. First of all, you can perform a barrier just to synchronize all your process. There are also other communication like broadcast, getter, scatter, and global reduction operators. Here only a simple example. Okay, don't worry, here there is only a print, it's not important. An example of a broadcast communication, okay, using the function bcast. What we are communicating here is a dictionary called data, okay, and look here, we are initializing data only for the rank 0 and not for initializing to none for the other object. What is known in Python is a special object used usually as a placeholder. You can consider it a null object, null value object, okay, like the null function in C, if I don't know, or the void type in C, okay. Sorry, I don't know very well the C language. I'm a old Python Fortran programmer. And so here it is performed the broadcast, where you need only to specify the data that you want to send and who is the root. That means who is the rank that send the message to the other process. Okay, this is the last slide for this presentation. Here you can find, this is the link for the documentation of this library, the MPI4Py module. Here, in this page, you can find a tutorial with some other example on how to use the. It could be a good idea to take a look on this. Okay, you can see there are many other examples on how to use MPI communications functions, both for sending communicate Python object or NumPy arrays. Okay, so of course it's not useful for you to read everything now, to know everything now, but simply know where to search the data, that the information that you need. And finally, here the API reference website. Also, this is really interesting. Okay. For example, here you have the MPI object and the com class, and here you can find all the function with a very small description, and in particular what you need is a list of all the arguments, and also, for example, here you can see the receive function. There are some default values. Okay, so this is why you can decide to use all or only some of the arguments when you call the function. So In that case, you can also, in some function, you can click on it and find a not so longer description. Okay, and so on. And I think, yes, it's all. It's, I think it's better point to stop for the lunch.
Before the time it take to conclude the sequence.
Oh yes, we can check if the run is concluded. What? Yes, perfect. So, yeah. Okay, we can see that there are two files. The error file, empty, is a good news. when the first thing that I do when I want to check if a run is run properly, I check if the error file is empty or not. The output files contains simply number of elaboration 3000, elaboration time. Okay, this number we can check how many. This is in second. So 26 minutes, more or less. Okay. Perfect. We can stop here for the lunch, and in the afternoon we'll parallelize in two ways, in two different ways, this Python code.